And we are live. Welcome back to the stream. This is Junchan, and today we are back on our Haskell learning track, and that means specifically trying to run an NBody physics simulation in Haskell on the GPU. So if you're here for, let's say, advanced GPU programming in Haskell, we are not there yet. We're setting up tooling, and it's been a bit of a journey because I'm not super familiar with Windows, and I've been using this Windows machine and trying to set things up here. And the Windows path for Accelerate is not very well signposted. It is for macOS and for Ubuntu, and so that's always a possibility, right? I am reserving the option to actually switch to one of my other partitions where I have these more sane operating systems, and then install, all of the streaming things there. But it would be nice to be able to tell a Windows story here, and so I am being a little bit stubborn for at least for the beginning of this stream. I'm not going to commit too much to how long I'm going to stay stubborn about that, because it is quite tricky. One of the possible outcome of that is that we might have a blog post for it, and where we have been so far is that we've tried to install things with Chocolatey, but that turned out to be a bit of a dead end. And we're now following the path of using the mingw 64 environment that has this pacman package manager and a package registry that seems to include what we need, which is, one of the things we need, which is libffi. And on the back of that, what we tried to do last time was to, in fact, I think we have more than just libffi install. I think we have GHC as well. And I think, what is it, -QA? No. I think -QS GHC or stack. Do we really have things installed here? Let's see if we have access to our packager config. No. So that, I think, is because how we were setting our environment needed this. And now we should be able to, we are, and I think we have GHC also 884 installed. And do we have stack? We do not have stack. So maybe that's a thing to install stack here, but maybe I'm getting ahead of myself. Let's go back to these install instructions. I think, it seems like we might be needing a couple of other libraries, like llvm. In particular, llvm is going to be useful because if we are to do some GPU things, then we will probably need this llvm backend for Accelerate. So, but let's first check what this thing is, FFTW. Oh, Fourier transform library. Okay. And so, so there was a pacman mingw 64 registry of sorts. Base packages. So that seems to be part of the MSys2, I don't know, effort project. I'm not sure how these things relate to each other just quite yet. But okay, there's some base packages. We have a search here. So let's try FFTW, and we have it. So that's pretty encouraging. And let's see. When we install libffi, we installed it with a slightly different package name prefix, which included the architecture. Oh, and it seems like we are actually sourcing GHC from our Chocolatey install. So that's a bit of a mix of things. Say, hey Juan, what's up? Good to see you. Doing well, doing well. I am, you know, testing whether I have the stamina to do the full-time 8 hours of work during the day and then an hour and a half of streaming during the evening, and it's full on, I gotta say. But you know, 2 days in, it seems like at least I have the motivation for it, and I'm in fact also happy and eager to be progressing on this. I want to see some pretty NBody simulation, you know, on screen, and stream that to you all. How are things going with you? So prefix with the architecture seems to also work, so that's good. Yeah, sounds good. Okay, so FFTW, check. So we can add that to the package list here. Oh, except I need to remember the correct keyboard shortcut for alacrity. Okay. And then llvm things. So let's see what we have in store. Ugh. Yeah. Okay. Let's see if they're in the broader. Yeah, they are in the broader universe of packages, including with our x86 prefix. So that's awesome. Let's install it. Oh, and I seem to have been using this prefix for a thing, but not for the other, weirdly enough. I wonder whether that that prefix is useful at all. I suppose it's not. But yay, we seem like we're going to have an LVM. And then it seems that some of the next things will be, what did I do with my, oh, yeah. Well, oh, so this is actually version 11 of LLVM. Interesting. So, well, there's a question about whether we're going to have to downgrade this because we might not be compatible. There was a table somewhere in one of our links And in fact, I'm going to clean things up here. This is a little bit out of control. You know what? I think this was in fact in the previous log. Right. So yeah, that seems to be the LLVM things, and I think it had indeed a table there, and we see that it goes up to 9. So we'll need to downgrade. That's pretty clear. Let's see if we can see the older versions. I mean, the version is in the package name there, so I doubt it. Okay, outdated, huh? Suppose that's okay, but those are the base ones. So how are we going to get? Okay, so those are the okay, sounds like this would be this. Let me check with little search pacman install specific version, older version of packages. That's exactly what I meant. Look at repo. Okay, what is this? Okay, well, this is pretty much where we were heading, and so LVM. Yay! Version 9 is there for us. How awesome is that? 9011. I like this. Definitely this package, so we're going to remove this. I think it's -r. Actually, you know what? I think it's not, but let's still try. No, it is. So we should be able to do now, oh, right, instead of LLVM, do -9 0 1, oops, 01 -1. 901 probably was enough. Okay, doesn't want to. Maybe we need to put the whole, you can go. The whole -ne or what? Oh, I see. We can download it and install it with blah. Ah, I see. Okay. Well, let's do so then, and let's update our blog post. So it won't be this. Instead, it will be something like, do we have wget? We do. So let's wget this guy. that's nice. But probably it's not MD5, right? But it's not clear how we get PGP signatures. Oh, they PGP. We do. Okay. How do we do this? Verify. Okay. Right, we need to, do we need to get the public key from, we probably do, right? Public key from these guys. So that would be this key, I suppose. And can we just download it? Or we need to download it manually. I suppose there is a command to import it, but where am I, by the way? Right, I remember there was an aborted copy of this. And okay, home June. Because I tried to do a symbolic link in there, and I think it just did an actual copy, which was a little bit surprising. So we'll go into, what was it? Was it in dev? Oh, I think it was in shared. Yep. Here. Well, really, let's do it here. And actually, let's move where we had our package here. And then let's vi sig.asc. Oh, really? Well, install that for me, please. What did I say? Yeah, sig.asc. Oof. Not right. Hey, welcome back. My job is I'm a backend operation engineer at Wire, which is a company that does the Wire instant messaging app, which is a secure and private alternative to like things like, well, I guess WhatsApp and whatnot. Although WhatsApp these days is not too bad around encryption, but you know, they're still a subsidiary of Facebook, so it's in their advantage to get all of your data. So yeah, I'm helping them with their Kubernetes operations, and their the fact that they also have enterprise clients to which they deploy their server solution. So it's one of the rare open source solutions that has a backend story as well as you know, good client story with good iOS and Android and desktop, and with pretty modern UX. So you can check it out at wire.com. Cool. Okay, so maybe I'll do it like this. I'll add a folder to the workspace. It's not the, well, no, that's fine. Can do that. It's a little bit strange, but let's see. Yeah, there are a few alternatives. There's Signal, which is also open source, and in fact, hey, Carter, how's it going? Mostly through their enterprise clients. I mean, through their enterprise clients. Yeah, the alternatives to WhatsApp out there that are also open source are Signal and Telegram, although I think Telegram is not completely open source. I think their crypto is not open source, whereas Signal is. And in fact, the founder of Signal, the lead dev of Signal, Moxie, is also, well, he's a fairly well-known cryptographer because his protocol is actually now in WhatsApp. And it's also a variant that's used in Wire. So it's the double ratchet encryption protocol, I think it's called. Yeah. And so what am I doing now? I am trying to verify the signature of a package that I just downloaded from this registry with an LLVM that should hopefully work with our the accelerate-llvm backend that we have in Haskell. And so I need now to check out the signature. Oh, I already did. So I suppose I could wget it as well. That might be a better way to do things. And then how do I then do my verification? Okay, we need to check the key's fingerprint first. Okay, so let's do things correctly. Trying to guess what we mean. So I guess we do want verify. No. Signature. No. So apparently this doesn't give us the fingerprint. Oh, fingerprint maybe. Okay, let's try again. This signature, yeah, fingerprint. This keys and fingerprints. Although that might be just loading our database, but let's try. Yeah, right. Hold on. Is this? No. What do you mean? No public key. It is a public key. Okay, I'm confused with GPG. Clicks in list keys. List keys. Verify signature. I have a public key inside sig.asc. GPG. Check fingerprint. GPG version 2, maybe that's what, oh, spammy spam. What is our version? It is version 2, so maybe that's the problem. All right, I see. Wow, indeed, there are quite a number of additional options. Okay, we got a fingerprint, and we got it from here, and the fingerprint here is 877.8078. Okay, correct. So we can import this, and I suppose it's going to be a whole other. I guess we don't have is -n the dry run. Let's understand these. -n is the dry run. So let's import without the dry run. Okay, and now we can verify things. So except probably it's going to be different with GPG2, but let's try. GPG verify, and we've got our blah, and we've got our blah.sig and invalid packet. Oh, thanks for that. Invalid packet, huh? Please remember that the signature file should be the first file given on the command line. Well, no, I didn't remember that for the reason that I just misread the instructions. Ah, okay, so it's a different key. We're getting there, so is that this one, the A01? Well, let's check it out. Fingerprint 5F. So no. Oh, A0, that one. No. AD35. So none of those. Well, I suppose it could be because those are old, and oh, there's a pacman key thing. Maybe I should try that. Pacman, okay. Pacman key, minus verify, and signature. Good signature. That's good. That's very good. So we are ready to install with this pacman-u. Yes, please. And so we'll have ourselves a an LLVM version 9, which is grand. I hope this includes whatever headers we might need. I didn't see anything devy in those repos. Yeah, so let's hope it includes all of that. And so we have, it seems like we have our 3 dependencies. I don't know if we're going to need more with MSys2. I'm going to call it MSys2 because I can't say mingw64 anymore. It's too long. Okay. All right, so we have LLVM. Is that true? Can we do this? I mean, I've never used LLVM before, but LLVM. Well, yeah, we have things. We have things, and I don't know. Is there the C++ dump, C test, verified? I've done DLL tool link. MC. You know, it would. I don't even know whether there's actually an X package story for Windows. Could be. Oh wow! Hold on. What did I just see? Corner of my eye. Nix package manager works flawlessly in Windows 10 creator update with Win. No, I'm trying to avoid WSL. Yeah, I know. I know. That's why things are hard. But, you know, a little challenge. Yeah, I have this machine on Windows. I was talking about this in the intro as well. You know, I've started Nix because of this new job that I got, and they are also starting to introduce Nix, and so I was doing Nix on macOS, and that's also a little bit painful. And apparently Nix on Windows is just not a thing, and I don't want to do WSL because I want to have well, you know, I mean, because it would mean that I need to reinstall all of my streaming setup on my Ubuntu partition. That's nice. Also, you might know something about something that I came across today. I was having trouble to compile things that depend on Cocoa, because it seems like that the Apple SDK Nix package repos haven't been maintained to upgrade to the more recent Apple SDK stuff. And the stuff that I saw on GitHub was like Xcode 5.1 or something. So really old stuff, and it seems like it's not updated. So for most things, it seems like it would work, but specifically for Haskell, I think fs notify depends on HFS event, and HFS event depends on Cocoa, and I couldn't make that work properly. It's a big question, huh? Okay. I wonder if I need this. That seems like that's libc, and it sounds logical that I would need it. And it's a bit, oh, right, because since it's not packaged, okay, let's see at what it's installed when I installed the version 11. Let's hope I have enough buffer here. LVM, yeah, that's here. No, oh wow, it installed Z3. How strange that it would install Z3. But it didn't install any libc stuff. Okay. Right. So yeah, basically I think it's possible that for me to just install Xcode locally on my machine through the, you know, external to Nix, and then basically then ask Nix to fetch that. So it wouldn't be really managed by Nix packages, but I guess that's the workaround. Okay, so this, right, I need to write my these steps I've taken to download things and verify things and whatnot, right? So let's do so. We have where a couple of wgets. This one. Right. Yeah. Makes a lot of sense. But it's totally lovely, and yeah, I wish more of the world used it. But right now I am making a little visit into Windows hell. See how I can orient myself here. I mean, you know, I know that whatever I learn here, the day that I want to package something to release it in the wild, that would include targeting Windows, and so I will bring that knowledge with me. Right. Do you do any Haskell on Windows? Yeah. What, C# or F#? Okay, so good with that. I think we're good with that. Yeah, I do want to test a simple, how do I test LLVM quick start or something? Getting started. Version 12 now. Yeah, no, that's... LVM 9. C#. Yeah, that's cool. Very cool. Yeah, F# looks like really nice. I don't know when on stream I came across, oh yeah, it was this blog post on CRDTs, and he was using F#, and I think it had an implementation for RGA that I was looking at. Yeah, that looks like that was it. And I was just looking at the code, and I was like, wow, this looks nice. Yeah, and plus there's all of the link stuff, right, with .NET, and so that's actually pretty edgy stuff. Sure, definitely not. And maybe you also, I don't know, like the type systems, how abstract you can get with F#. But link is one of those things that I wish we had. Yeah, definitely. Yeah, still an improvement if you're into FP, then upgrading from C# to F# should be a pleasure. Okay, what am I doing? I wanted to try and see if there was some way to test an LLVM install. But you know what? Maybe I'll just go back to just try and build. Oh yeah, and yeah, my Haskell tooling, I might need to update that. So let's see if I check, if I search here, maybe see if there is a stack. No, but there should be GHC, right? No. Oh, right, I'm looking in base packages. GHC is not there either, and stack is not there. I see. Well, it seems like I was able to actually get something from outside MSys2 that's using Chocolatey to properly run. So maybe I shouldn't worry too much about it and install it with Chocolatey. In fact, maybe it's already installed. I need to check, I suppose, here. Oh, right. Yeah. So doesn't go as high as types can go. Do you do a lot of Haskell? No, I have Cabal and GC here, but not Stack. Chocolatey Haskell Stack. Yeah, it's here. Okay, so let's install. Let's install Stack through Chocolatey. I don't think I can use Choco here, can I? Oh, I can. Okay. So what if I Choco install Haskell Stack then? Yeah, you know. Oh, that's funny. 6 years ago. That's pretty much when I also discovered Haskell, you know. And I was doing JavaScript, mostly front-end development. And yeah, got bitten by the functional programming bug then. And then, you know, I definitely started to change my writing of any code and started with personal projects too. And now I'm trying to do it for most of my projects, but, you know. And I do both, yeah, Haskell and PureScript. Okay, so that's okay. Downloaded it, but oh, okay. There's some rights issue here. So, oh, probably because those paths actually don't work in here. Do they work in here? Let's see. I'm checking it out. Well, mostly PureScript and Haskell. I just got hired by a company that uses Haskell in production for all their backend, and so now, yeah, I do Haskell professionally. So that's pretty awesome. That's very cool. Yeah, I'm super happy about it. Ah, yeah. You can use link. That's super awesome. Yeah, I've been looking a little bit into this particular question of how, like, you know, the range of DSLs that are out there in Haskell for databases. And what is the one that I was looking at? It's Beam, I think. Beam has a nice story for query composition. Using a monad, right? Haskell Beam. Actually, I want the docs. This doc, yeah. Not the tutorial, user guide, I think, and queries, basic queries. Here. This is not the easiest example. No, that seems like that's just a product. Complicated query. Yeah, I don't know if that counts really as composition. I thought there was a better story for composition. in that Q monad, which is your DB monad. Hey, thanks, Juan. Yeah, I'm super happy with where we're going with Chronofault, and I can't wait to go back at it tomorrow and have more fun with it. The schema is type level, but basically it builds SQL query in a type safe fashion. The models are higher kind types, so you pass your database types are annotated with an HKT pattern, and then that's used to do type safe generation of SQL. So that's one of the ones that I prefer. You know, there's also Opoli. Sure, I think you can actually drop into doing that. Or maybe it was this, by the way, combining queries. Union. Yeah, I think you can always escape to low-level SQL, you know, unsafe SQL something, right? Very cool. Okay. So, okay. Oh, and you also can't access this path. So you know what? I'm not gonna bother. I'm not gonna be too worried about this. I'm gonna fire up the PowerShell and install that that tooling with it, because it seems like I can access it from inside MSys2, even though I can't install things into MSys2, but that's fine. Okay, what's going on with my search button here? Strange things. Visibly, I can't click on it, nor my... Okay, super laggy. PowerShell. I don't even know how to get to the PowerShell from this menu, actually. Come on, give me back the search. I also have restarted my computer, like... Oh no, that's not true, actually. It was sleeping, but then how come can't run the search? Windows, such an ugly beast. Ah, there you go. We're back. PowerShell, and I'll run as... Oh, maybe it's because I'm not running Alacrity as administrator, of course. That's probably what it was. Although I seem to be able to install packages fine, but maybe Choco needs it. Okay, Choco install Haskell stack. Oh, I'm doing this off screen. And yes, please, to all. Yeah, I mean, downloading actually worked here, so I shouldn't be too happy, but yeah, so the thing we'll need to do here, though, is make sure that we add basically Choco install Haskell stack, right? And then we'll need to add stack here, which feels very inelegant, but I think it will work. Okay, it was successful, and it's right there. Perfect. And we need that path, except we need it in that other version, so I'm going to write manually instead. Chocolatey lib Haskell stack and tools indeed, and then what's in there in the tools. Show me this, please. Stack exe. So we don't have a bin here. We can just link this directly in the path. And let's export this. It's gonna pollute my path big time, but hey, whatever. Stack minus version. We get stack installed. 251, that's one of the most recent one. Lovely. So now can we at least finally do something that's a little bit more Haskell-y? I think we're getting ready to do this. I think so. We might want to do that ln command. We are not in the right folder. We can do the ln here. Okay, now we have a stack.yaml. And then let's take a look at the build targets. There aren't really build targets here. And I thought we used hpack and did some stuff with hpack, but we didn't. NBody, main. I thought we'd interpreted the stack YAML and create. Oh, we probably did actually. It's just here, and I couldn't see the cabal. So yeah, maybe we didn't need stack. Yeah. So in fact, I think I was in fact doing more of cabal things instead of stack things, which I think let's try with cabal for now. And in fact, I also linked the wrong stack because we were doing Haskell 8.8. So let me remove this and let's go back to trying with cabal instead. And I think what we're doing is something with cabal build -f for the flag and body. I think cabal build -f and body. I think that was the command. So let's add this. Okay, and then well, I guess I don't have anything about installing Accelerate here, so let's say something about that. Git clone. We git cloned Accelerate examples, so let's reference that. Yeah, this repo. Oh, it would be nice to look at the code again. So let's keep that open. And then get the Git repo. And what else? Well, let's do the SSH version, right? I think that's our actual upstream, but I will check. Oh no, we did that from HTTPS, but probably shouldn't have if we want to commit something, but okay. And right, so cd accelerate examples, right? And then we did hpack with stack 8.8 YAML, I think, right? Let's move you here for a sec. Stack dash 8.8 YAML. But where did I get hpack from? I think I might have done that in the other environment. Let me check. So yeah, we're starting or continuing to build. I hope it's continuing. I think it should be continuing rather than starting, which would be great news. I should have actually run the command before doing all of this install, but let's assume that I got everything right and that we actually passed some of the errors that we were encountering last time we tried. So let me then start Alacrity again. And test whether HPAC is accessible. It's all good. Welcome back. And let's check. How are we going to check that? Well, I'm going to add these path items. Copy and paste, and it's not pasting. It's actually not even typing. Can you not deal with two terminal open together windows? What's your problem? Yeah, well, life is hard in Windows land, huh? Poor thing. Oh, I shouldn't shake that thing. Okay, all right, so what about pkg config path? That you forgot? Ooh, wow. Pasting again, such a hard job. Such an incredibly computer intensive operation. Pasting in the terminal. Ooh. I wonder what's going on. I wonder, it might be because that MSys environment is somehow running in the same underlying VM or runtime or something. It's actually not even copying right now. Okay, it just copied. Okay, and now if I type something, yeah, no, you don't want me to type anything? Okay. I see. Okay, so back to our PowerShell, and here I do have HPAC. Yeah, I do have HPAC. And where is this HPAC coming from? Yeah, you don't know what which is, of course. Well, how about we bash you? I'm going to WSL, I believe. Well, oh, well. Okay, things are happening over there. Okay. Control C. Clear. We'll get there. It has a life of its own. Yeah, we don't want to... okay, clear. That wasn't as terrible as I would have thought. And do we have access to HPAC here? We don't. Yeah, so probably something I also installed with Chocolatey, so I would assume that it's visible somewhere like here. It's unclear where it's coming from. It could be, well, could be Cabal, I imagine, but it's not. Well, actually, this is a repo, yeah, but still not. Maybe in Haskell dev then. But no, that doesn't make sense. Okay, well, forgot how I installed it, HPAC. That's not great. Let's What about my documentation? Windows 10 HBack. Haskell. Oh, I think I did cabal install HBack. Yes, I did. How do I know which software cabal install? Where does cabal install its stuff? Install dir config file .cabal. Okay, let's find all these things. First of all, will this work? Yeah, I didn't think it would, because our real user environment is in fact here. Is there .cabal here? There isn't. Okay, back in Windows land. Dir home .cabal. No. Oh. Holy moly. That's where it goes. Application data cabal config. Okay, see documents and settings, join application data cabal config. Well, actually, yes, there is a config here. Lovely. Okay, so we know where things go. So maybe we should write it somewhere. Because I did at some point Choco install. Maybe I did Choco install Haskell dev, in fact. And that might be a virtual package for GHC and cabal, I think. Choco install Haskell dev. GHC and cabal. Yeah, that's right. And then I think I did cabal install HBack. And I think that this basically, well, in fact, it should also be part of the stack toolkit, but I'm not 100% sure. So let's keep an eye on our, but we've installed stack already, right? Oh, okay, we have a fail, but that's for the CUDA package, and that makes total sense that we have this error. Yeah, break time. Excellent. We know where we know what we'll do when we break from our break. We'll check our CUDA library version and path and all the things. And see you in a bit. And I'm back with half a banana in my belly and water, and quite happy with myself. Still kicking after a full day of work and an hour of streaming. But I'll keep to my hour and a half, and see whether I change that next week depending on my stamina. But yeah, we have 20 more minutes to go, and it seems from the error message that it actually found a CUDA toolkit, which is great because indeed there is one installed, and it's just that the probably that the well, the version's not right. I'm not sure what this NM means there. But we are going to downgrade our CUDA toolkit to 0.10.2, and I think this is completely in line with what is around here. In fact, hold on. Yes, 0.10.2. Wow, right, 0.10.2 must be CUDA 10.2. Also, it is... but hold on. What is that going to mean with regards to llvm and the CUDA version? Could it be that, in fact, we are able to do CUDA 10.2 despite this not being on the table with llvm 9, despite it also not being on the table? Oh, hold on. NVMM... Also, it could be that maybe it's just when we use NVMM that we have that this table applies, whereas when we don't, then maybe we have we're able to use a slightly older version for our CUDA toolkits. So let's see if we can how hard it is to find an older version. So that's the 11.2. Archive our previous CUDA releases. That's what we want. 10.2. And that's a big thing, but hey, I got a okay connection. 10 minutes. Well, that's one of the things that I could do to improve my streaming environment is have a better point-to-point, either have a better point-to-point Wi-Fi link between my office and my router, or just bite the bullet and extend the cable all the way. I am supposed to have 100 meg download and 50 up, but yeah, let's leave it be. And yeah, I was going to write that cabal install hpack little comment saying that this installs. Yeah, that's what I'm thinking. I have a Wi-Fi sort of extender slash repeater that's not very good. It's quite old, and I think I could start with that. But also, I think my router's Wi-Fi might not be the fastest, so I might actually do like a point-to-point Wi-Fi extension to my router. So I think we found out that this was installing things. Right, probably here, in fact. remote repo cache. Hold on. Right, ls. Yes, there's a bin folder here, and we have HPAC in it. Exactly. So yeah, so far, in fact, the idea is that this would be in PowerShell. I think this can probably be improved, but that's my log. I mean, it's supposed to be a blog, but I did that in PowerShell. And then I moved to Alacrity with sysbash. And so I just wanted to say where this is installed, and it's installed here / bin. / bin. Right, so if I want to run HPAC from here, then I need to do the little dance of adding this to the path. There we go. And so that should allow to do HPAC blah, and we shall test this. Oh, right, but I didn't do the path augmentation, and I keep adding crazy things on top of my path. Ah, right. I suppose this, right? Yeah. So let's try HPAC. It does work. It's ignoring some stuff. And it wants us to use -- force to overwrite, which is exactly what it should do, because we might have made a modification and it's not going to overwrite it, but it works. So that's all good. And so then after that, yeah, the idea is to do cabal build -f of NBody. That's what we want to try. And oh, is it? Well, yeah, I guess my download is bringing my connection down to its knee. Yeah, I see there's an unstable network detected here. Sorry, it's 4 minutes left until the connection's back to breathing. It shouldn't matter, right? But I think it's probably because of Wi-Fi not being as good as doing full duplex as an Ethernet cable would be. So probably a wire would be the better option if I wanted to be to fully exploit my bandwidth, a wired connection. I probably want to download those patches as well. But yeah, in the meantime, let's see. Building from source, LVM source code. So that's building LLVM from source. Right, and so I assume that this would do pretty much exactly what our HPAC and then cabal build will do, but we can sort of try and convince ourselves that that's the case. By, I guess, looking at the stack. It's going to be doing the LLVM things. Uh-huh. So it might be the case that that none of these examples are actually using the LLVM backend. Or that I might need to specify them when I build. Yeah, I think that's the case. I don't know if I should assume from that that all... Oh no, hold on. Oh yeah, no. No, that's the test that's the test harness. It's a test harness, but seems like... I don't know, it's if it's library, then it's not just the test harness, then it's... Then I think this is imported as well, right? In the executable will import the options from library. Huh, maybe not. Main is blah. I'm pretty sure it would. I think by default, the executable section in the Cabal file would import the library section. Yeah, I mean, I think so. And actually what it will do is pass a CPP option. So that might be for the... Oh, it's installed. It still says unstable here on my stream manager. Let me reload it. Okay, it doesn't say... Oh, it says excellent now. So I suppose we're good again. And however... Ah, there we go. Package launcher. Boy, it's taking a lot of time. Okay. And I'm gonna try to install both. That might be a mistake, but let's see how it behaves. In any case, it wants the installation wants CUDA, even though I didn't even pass the LLVM PTX flag. And what's going on with my install? What's happening? Solver, size, frame rate, row trees, bodies. Right, it does use this is the library that's being imported that we saw in that Cabal file. And so that will be built with accelerate-llvm PTX if we ask it to be here. That's the one. So that's the one that I suppose if we, yeah, that does mean that we will need to build with the llvm PTX flag. That's for sure. I'm not super clear why. Well, maybe it's just a way that that this is set up. It's not a very granular way to build it. The fact that it still needed CUDA and all of these things, despite me not specifying this flag, but I presume it's just that because it's trying to import everything it's going to need. Which really is, in fact, this dependency. In fact, maybe this dependency by itself must trigger the need for CUDA. Okay, so that's great. And then if I look at lib, then can I see C++ macros that will wrap things in a way that makes sense from the backend standpoint? LVM, yep, I do. If def statement right there. Exactly. So we'll if def and import the right dependency. And this is happening now. Yeah. If def will change the backend, so this flag will actually use this CPP macro to get us on the GPU, which is what we want. Right, and we do want to download those patches. Because we want all things new and shiny from... Actually, those patches are really recent. But 10.2 seems like it's a bit old compared to, yes, November 2019, first release. Still pretty good. In fact, I'm really impressed because, yeah, there's, not enough population in the Haskell ecosystem to keep things tuned into 11. Meaning, following all releases of underlying infrastructure, and 10.2 is just a year old, so good job. Still doing compatibility checking things, whatever that means. Concurrent backends. By default, how many instances of the backend can be run concurrently? Both the llvm CPU and llvm PTX backends are safe to run concurrently given the same execution context. Hold on. A multi-core CPU backend may specify just one, so that only one instance runs at once and it inherits all threads. A thread-safe accelerator backend can specify nothing, while a non-thread-safe backend perhaps it requires exclusive access to the accelerator should specify just one. Oh, so nothing means just parallelize as much as you want. That's pretty cool. We inherit the RTS options. I see. So do we need to pass special RTS options, or are they included in the cabal file? Not sure what those are. Memory, but for some runtime things that I don't know. EKG, I know. It's in case we want to have a profiling tool. Okay, Okay, so those are the RTS options. So those don't seem to include, I mean, I know of parallelism options, but let's document ourselves with this, about these GST options. Thread affinity. Okay, no, please give me documentation. Keeping compilation fast. Okay. Oh, I know. Minus means don't use this. Okay, let's keep this here. Really? You're kidding me? You still have this? Minus n to, okay. Default for m with blah. When set to non-zero value, this option divides the allocation area value into chunks of the specified size. So 2 megs. So there's chunks, allocations, the allocation what? Another chunk from the pool, allocation area. So allocation area must be some kind of pool, minus a, set the allocation area size, used by the garbage collector. Ah. Okay, let's see. What's the by default? Everything. CUDA, runtime, Visual Studio integration. I'll keep those because they might be useful. CUDA compiler, NVCC, if I understand correctly, is the NVIDIA CUDA compiler. All manners of tools, runtime and demos. And by the way, they should have an NBody simulation demo, but written in C++. I don't want to compile it. I don't want to run. I don't want to fire up Visual Studio. I think I do have Visual Studio, but yeah. Okay, fine. Do your thing. Yeah, that sounds like the correct locations. And okay, so and then what's minus QG? Use parallel GC. I see. Well, I mean, I think the GC itself must be running on the CPU, right? But oh, it does, but it's parallelized between the cores. That's a beauty. Wow. The value of minus n or the number of CPU cores. So yeah, but automatically it goes on all cores, and therefore the GC is done in parallel. Yeah, so that's one of the benefits of being in the Haskell world, is that really the GHC is really, and its runtime is a marvel of modern technology. So that's pretty awesome. Plus, there seems to be new improvements on GC performance coming down the pipe for, if not Haskell 8. What is it, 11 next? Then maybe Haskell 9. That could be close to the next version. Okay, where are we with this? Still installing, and I guess a little past my, not my bedtime, but my stop the streaming time. But now I'm excited to see whether this is actually going to at least get us to the next error message. So I will hold on until we get there, and I might actually also, first I'll install the patches, and then I'll rerun Cabal. Okay, so those are cool things, and then yeah, let's look at the code for the NBody example again. Yeah, because last time we saw that it was kicking off from with these steps. And it was using advanced world and advanced bodies, and I think that these were defined here. Yeah, advanced bodies, advanced world. So these are the real calculations, or at least entry points, because it seems like that goes elsewhere. But the real calculation of the physics simulation and advanced bodies, I suppose. Well, so function to compute acceleration at each point. Okay, we get past. It gets past. Right, so advance is passed to simulate, which is passed to the engine. And advance runs advanced world with step, and advanced world takes the step, and then when given a world, returns a world. And the world includes all of the bodies, steps, and time. And as part of this function to update the body positions is this, which uses the backend to run this advanced body simulation. This time, I think, inside our AC monad, which is the accelerate monad, whereas in here we weren't. So now we drop inside the accelerate monad, and advanced bodies is a GPU, now a GPU parallel all of the goodies computation. And I'm going to put this here so we can see it. And then what do? We get past a function to compute acceleration at each point, which is a function on acceleration, and that is given by a solver. The solver, right, calculate accelerations, and so that's the main thing that's going to be running in the backend. I'm not sure whether we care so much. Well, these things are in fact, yeah, that basically these things execute the calc accels for a given time and a number of bodies. So this is a bit like the interface between in our case, the CPU and the GPU. In here, we'll still be, I think, on the CPU. And then when we pass a scalar time to advanced world, it will be lifting that into the AC monad, and that will probably mean passing it as some parameter to the GPU. So maybe copying some value from either a CPU register to a GPU memory place, or to some RAM, main RAM to GPU. I mean, for a scalar, I imagine that's a small thing, but a vector of bodies, that's going to be a bunch of things, like up to thousands of bodies with their three-dimensional coordinates, I suppose. I mean, this vector here, I think, this linear vector, that must be a traditional 3D vector. Well, actually, we have also 2D vectors if we want, but and all manners of. Can we choose that? Maybe it's an option. It could be that it's an option. Well, if we import data array linear vector and we say vector body. Oh, yeah, of course. Vector body just is an array of bodies. Bodies will be defined somewhere else in common body, and these might be, might have three-dimensional components. But A vector of bodies just mean an array of, let's say, thousands of bodies. And so let's take a look at the common body. And yeah, that will probably use V3, which are three-dimensional vectors, and indeed V3. And so it seems like we're building things in the EXP monad here, which must be what gets in the end compiled as GPU shaders. Okay, we're fine with that. I wonder what launch samples does. You know what? Let's try it. Oh, okay. Yeah. As it's just the Visual Studio samples, and there's simulations there. There's our NBody simulation, and that is a beauty in itself. But I want to run it in Haskell, so we won't see the beauty. We'll install our patches that I just closed. Downloads. Downloads. First patch. Express is fine. It's finished. That was nice and sweet. And same here for dispatch. And we are ready to try and compile again. This time with the llvm PTX backend. And that's a lot of moving parts. So, I doubt this will succeed. Or even if it succeeds, it's very possible that we would get a runtime error. But hold on, look at this. Well, it's starting. Yeah, I shouldn't shout victory yet. We're starting to build. If it says building, that'll be some good news, because I think it will mean that it has found its dependency. Well, first of all, it's okay with our llvm backend, and that's pretty cool. Let's see, where did it fail exactly? Okay, let's keep this here. And here we have the equations for the NBody problem. And we look at this in more detail, but I think EXP is basically the kind of the computational monad. I think that's where we lift, that's the DSL where we do calculations. And AC is the broader monad inside which we do not just computation, but also things like storing values. Right, so advanced body. Hold on, before I do advanced body, I wanted to see the type of body. What is the type of body? Yeah, this is exporting the type of body. So body. Okay, but okay, so maybe it imports it from somewhere else. Oh, maybe from common type. Yeah, we had that before. Common type, and I don't don't see building of CUDA yet, but it's still good news. And right, v3 and body is three things. It's a mass, which is point mass, yeah, which is the position and its mass, a velocity, and the position is a vector of reals, and the mass is a real. Well, a float. And velocity is a three-dimensional vector of floats, and acceleration is a three-dimensional vector of floats. So this all makes perfect sense. That's the way we definitely want to think about our problem. And then if we go back to this simulation, then maybe we look a little bit at the code here. So calculate the acceleration on the point due to some other point as an inverse separation square relation. The force on the body I caused by its gravitational attraction to body J is given by blah. So force on body I is gravitational constant G, product of masses, varied by the distance between I and J, multiplied by the distance between I and J divided by its absolute value. So that's, oh, hold on. What do we have here? Configuring CUDA, found CUDA toolkit at blah. Okay, so it's still trying to look at the wrong CUDA toolkit. So I might have to delete that guy. You know what? No scruples. I will just delete it. Let's see, program files. Although maybe it won't be possible with the NVIDIA GPU CUDA v11.1. Maybe it won't be possible because of the permissions. Indeed, it won't. That's all right. I'll delete that from my off camera from my Explorer. NVIDIA Computing Toolkit, CUDA 11.1, delete. And then there was also an error about llvm, which is also not necessarily so surprising. Which it's a cannot determine version of llvm. We need llvm config version 9 blah, but the version could not be determined. So we might be able to because this is probably pkg config here, trying to do its thing, but not succeeding. But I think we might be able to fool it. So pkg config, I think minus mod version, right? And let's do it with libffi just to check that we have the syntax correct. We do, and then llvm config. Yeah, indeed. Okay. Right. It could be that the pkg config path is not all right. What is the pkg config path here? And right, it could be that this is installed somewhere else. Looks like it should be installed in here, but let's go and well, let's not go there, but let's peek at it. We don't have llvm here, right? But we do here, and we don't have anything that looks like a subfolder for nope. And so in lib Oh, well, we have a number of LLVM things here. So what's up with pkg config? There's no LLVM things here, unfortunately. So, well, as I said, maybe we can link them. I'm not sure how easy this is going to be. Let me take a look at one of these, like CUDA-libffi, for instance. The prefix should be okay. Exec prefix should be alright. libdir should also be okay. Toolexec libdir as well. Include dir probably. But we don't have, do we have includes for LLVM? We do. Maybe we have package config files here. Nah. Okay, let's do mingw no, 64 LLVM package config or pkg config. Aha. Someone got there before us with an older version of Windows. There we go. That's what we're doing. Yep. Okay, well, let's try it. Let's see if this works for us. It doesn't. So I think we need to install libstdc. I think we don't have libc installed basically. No, that's not what I wanted. I wanted libstdc ++-6. That thing. Oh. So there is this weirdness about where things live. The fact that we have a W32 and a W64, as well as I think other places where some of our package installs live. I wonder whether this isn't part of the issue. So let's see if it's in the 32 folder. But I think there's even another one that's not listed here. Aha. So don't I have that in my list of packages inside my path? I don't. Ah. Okay, well, I'm gonna add that then. I mean, I'll double check with echo path. This would be ugly. And I'm not sure I can see very easily whether this includes 32, but it doesn't. Cool. So great. That's a reason. That's a good root cause for failure. So we can do this. And then further destroy our path. I mean, you know, to be honest, I'm going to do path equal. Just check that it's empty and then do my ugliness. And so now, well, at least it runs. That's good. But the --lib thing seems to not work. But I think we can pop up the stack here. Says -l blah. That's not the case for us. But maybe it's okay. How about if I do ---- version? Could be that this is just an old thing. I mean, this doesn't say much. It's pretty silent. LVM, how about you give me something, maybe you're also pretty silent. So it could be that we're in a bind because our yeah, we mixed up with our, we can't have a 64-bit executable running with the 64-bit 32-bit library. Sorry. What? Okay, I visibly broke stuff. Oh yeah, because I had a number of other things that I was supposed to have on my path, and I simply removed it all, including the stuff that's supposed to be like user bin, user local bin. Yeah, okay. Oopsie. Okay, so we can again destroy the path, but then this time we'll be adding this to it, except that oh, I see. Ugh, that's ugly. Okay, fine, I'll do it step by step if that's how you need me to do it. User, and then what? User bin corporal. Oh my god, this is terrible. User bin. Holy moly, you've... Ugh. Okay. Die in a fire. And like Kemet would say, although I don't think he would say it in anger. Okay. And right. So at this point, if I do this, I should be in better shape, and I will need to do my package config thing, and then I'll need to go back to finding the proper folder for things, which in my case is what shared workshop experiments NBody, right? No. Oh, it's NBody from here, apparently. Yeah. And right, we were trying, well, clearly ls works again, so that's good. And how about llvm config then? Okay, it's still very silent. Okay. And how about, well, pkg config, llvm config, or mod version? Let's do libffi again, just making sure we are live and kicking. And right, llvm config. Still not good. Yeah. Okay, so let's see whether we can find some package config things in here. That's definitely not working properly. Conflicting lib from other unrelated software on the machine. Could be that, huh? Oh, there's an LDD function. Okay, well, I definitely want to try that if it's here. Yeah. And so llvm config.exe. Okay, yeah, you're going to want the actual path. Small fascism. And what do we have? std6. Oh, what? I thought you didn't have a libstd6 in this place. Did I not see it? I mean, it's weird. I thought... Oh no, it's here now. Oh. Well, I don't think we have that problem. We have a problem with the package config file. But it's worth relaunching the Cabal at this stage, because I'm going to well, I'm going to stop the stream. That's one thing, and then I'm also gonna want to see whether that CUDA fix did anything. And are we not in the right place? We are. NBody, I thought was the... Oh, sure, Cabal build. So let's see if the CUDA problem also somehow gets improved by our removing of the more recent library. And then, well, there's still a possibility that LLVM will actually work, because now it will find the LLVM config, or LLVM config won't crash because it has an libstd C++, but it seems like it's probably not working the way it should work, because I would expect it should give us something like minus LLVM9 or something. But who knows? And it seems to be asking the version of LLVM through pkg config. Right, and in fact, oh, check this out. Yeah, it will, apparently, at least with this build, it will not search search for LLVM config through pkg config, but it will execute LLVM config -- version. But we tried that and it seemed to output nothing. So So we might probably bump into that same error here. And so let's elevate ourselves from the mud of the interaction with Windows and DLLs to elevate ourselves back into the beautiful world of Haskell code and check a little bit more on this on the way that the NBody simulation is run. It's funny this, I think it's because of the parallel nature of Cabal builds that it's, even when it could fail, yeah, indeed, they could fail on the same errors. Each time it still installs something new. Yeah, maybe because it's running these different things in parallel. Okay, so I think that's where I'll leave it. Basically, what does it say? What does it say? It says that, yeah, CUDA 10.2 still can't find it. So we're going to have to check out how exactly that verification is done. It seems like it's linking to a setup file there from the library. Yeah, I don't know, but we'll need to check on this and what NM and run interactive process mean. And then we can't determine the version of llvm config, and that could be just because the the version simply doesn't work yet. So we have so we'll take a note of this, in fact, in the blog for a start, but then also put it in our log. Wrong shortcut. Okay, current state, and then in our log here, we can say that we need to fix CUDA 10.2 build and llvm 9 build. Let's call that fix. Okay, and that's it for me, and I will see you tomorrow for more PureScript, where we're working on our prototype, and which is a VS Code extension to publish this log first in a browser and then in a Twitch extension. So that's going to be fun, and we'll be back on our Haskell journey, Haskell and Windows journey on Thursday, hopefully with beautiful NBody simulation graphics on our screen. And until then, have a great time, and thanks for watching. Bye-bye.